We rely on our sense of touch to enable us to undertake everyday tasks, and it is the tactile sensations such as textures, bumps, contours that help to give direction and guide our movements. We are constantly using the information received by the sense of touch to tell us about our surroundings. If one aims to convey an idea to a blind person, he needs to use tactile representation for the communication purposes. For the scope of this project was to make Malabar Beach and Malabar Ocean Pool accessible for a visually impaired person and allocate tactile community center on the site. After performing a careful observation of the site, we spotted that the site had two distinctive tactile features. The unique rocky topography of the Malabar Ocean Pool, which was full of micro tactile sensations such as ridges, bumps, holes, and contours, and the abundance of banksia in the surrounding environment, which is also full of tactile sensation but at a micro scale. So we wanted to know how can the bumps, contours, shapes, objects, and textures of Malabar Ocean poolside be represented for visually impaired people? Is there a way to create an accessible and safe experience for blind people within this natural rocky topography? How can Banksia, which is full of tactile sensation, become a tool for accessible design? We researched the textures, growth patterns, and life cycle of Banksias and other seed pods in the first half of the semester. We decided to further focus on Banksia and link it to our existing site and take it forward. We scanned a couple of Banksias to further do investigations on materiality. We explored different methods and techniques to help with understanding the tactility of Banksia. We used meaningful and logical ways to reproduce parts of Banksia to make sure that they are intelligible by tactile means. To achieve this goal, every component of reproduced objects must be distinct and easily identifiable. For one of the fabrication methods, we tried laser cutting. We tried two different materials so we can study different textures, colors, feelings in the final products. Process 2 was extracting the negative image of Banksia and reproducing them using 3D printing techniques. Here are the final patterns of the 3D printing. These are the final results. For the next step, we put clay on top of 3D printed objects as a mold. Process 4 was milling a small part of Banksia. Based on our materiality testing, we found that the form and shape of Banksia, which was very unique, can be reflected as an architectural character. After revising our earlier research, we went back on site and studied it. Our design has two parts: walkway development and the community center. From the point of view of a visually impaired person, we mapped the obstacles on the pathway from the beach to the ocean pool. The obstacles are reflected here on left from low to high difficulty level. We did a SWOT analysis and narrowed down the areas which needed rebuilding. And then we researched on the potential design solutions like street markers, appropriate demarcations, and pathway maintenances. Here are the spatial map to help visually impaired people navigate through the Malabar Beach and Ocean Pool using different patterns and legends. One of our aims is to help visually impaired people explore what they cannot do. So we are proposing a system to make it easier for them to walk safely on the rocky area near the ocean pool. We are using the existing ridges on the rocks and expanding them as guidelines. We are adding a layer to these ridges with these indicators. A special stick goes into the ridges. By moving the stick through the track, they can feel these indicators and be aware of every obstacle in front of them. The stick would be given to them on the site. We are proposing this system for all the rocky areas, especially for making the building accessible for visually impaired people as it is placed on this area. After finding a way to navigate on the rocky environment of Malabar Ocean Pool, we needed to come up with a design solution for the tactile community center. For this stage, we wanted to create an architecture that is blended with the natural terrain of the site. And this is where our study and research of the Banksia came to our aid. While doing the material investigation on the Banksia, we noticed that Banksia, just like nature, has topography at the micro scale. We used this feature of the Banksia to create community center for this object. We dissected a Banksia and took out parts of it which could be used for the design of our community center. We deformed those selected portions by playing with the scale and proportions of them to make them comprehensible at a human scale. This is the inside view of our structure. This is the ground floor plan with the tactile tiles guiding the visually impaired throughout the structure. This is the spatial map of the ground floor plan. This is the first floor plan with the tactile tiles and railings on the edge. This is the spatial plan of the first floor plan. Uh, Further are the sections where you can see how people interact with the walls, ceilings, floors of the community center. After researching about the possible structural solutions, we decided to consider 3D printing as a potential construction strategy for our design. We broke down the structure in an ideal grid which would help fit the standard 3D printer frame. This is the process of the fabrication of the structure. The 3D printed parts are designed to connect each other using different joinery techniques like dowel joints. These are different members which are joined together with the help of a strong binding material. The walls of the exhibition area embody an informative tactile tiles which showcase the life cycle of Banksia. We got this particular shape by using the Penrose tessellation method. This would help us create multiple patterns with these tiles. These tiles were inspired by the life cycle of Banksia. These are the possible different iterations with the physical models. This is how a visually impaired person would interact with the spaces. As a potential tool, we also designed a metal strips skirting which would run throughout the structure. This would also help blinds navigate the spaces. For our user interaction study, we created this user persona. This is Lily Evans. She is 32 years old. She has been visually impaired since birth with some light perception. She lives in Sydney with her husband James and her son Harry. We created the storyboard to understand how the user would interact with the design. Here is the storyboard. Through this exercise, we got to put ourselves in the shoe of the visually impaired person and understand how he or she might react to the design. The purpose of the studio was for us to understand how a visually impaired person would perceive objects, surfaces, and spaces. By focusing on the life cycle of Banksia, we tried to amalgamate a few things together and attempted to design a safe, informative, and functional space for all. Thank you.